Hey everyone, my name is Devin. Nice to meet you. Excited to have you here in our webinar today. I want to talk about a collaboration that we're doing between Memfault and NXP. And it's going to be all about higher quality, better performing IoT devices with embedded observability. And really what I'm talking about is debugging tools, remote diagnostics, and how to use that with your NXP product designs. So I'm Devin. I am involved in strategic partnerships here at Memfault, working together with companies like NXP to help get our product easier to use for yourself and easier to set up. And my background is actually, I'm an engineer by training. I started off in embedded systems, mostly radar and signal processing and defense applications. I've been involved in a lot of high performance computing and high performance embedded processing projects. And I joined Memfault because of my excitement about IoT and smart home and automation technologies. So we're here trying to make those products better. And with me today is my good friend Kyle over at NXP.
Hi everyone, like Devin said, my name is Kyle Dando. I'm at NXP, and as my title below says, I'm in charge of MCU ecosystems. What does that mean? Well, it means I'm trying to work to deliver a better development environment for you as our customer. And so that's, I'll talk about it later, but that's why we are excited to work with Memfault, because we see that products are changing, the tools need to change, and to engage in the IoT product chain, we need a better development flow, and that's where we think Memfault is a great partner. So I'm looking forward to presenting with Devin today, and Devin, I think we got a good group attending today, so this is great.
Excited for it. So let's get started. So what we're going to talk about, the problem we're trying to solve today together, is the embedded development process. And it's really actually the entire life cycle of embedded development. Our founders here at Memfault worked in your shoes, building products with Pebble, the original smartwatch, Fitbit, Oculus, and they really struggled with this. And what they struggled with are the challenges of, one, the launches are always late. It's hard to get to market on time. It's hard to feel confident getting to market. And a big reason why is late in your development cycle, when you start doing your verification and test, there's so limited tooling to be able to, once you no longer have your hardware debugger, that crutch that you live on the lab desk, and your devices are out with beta customers, the time to resolve issues you're seeing and improve your final launch firmware is just really hard to do with the tools that we have today. So maybe you go out for drinks, you finally launch the product, it's out there, maybe a quarter or two late, but that's all good. We know the first year is basically a bit of a fire drill, even if you have a great product, especially now with devices that are really capable and really complex, allow you to do things like artificial intelligence and asset tracking and all of these things. You're going to find environments that you just couldn't test for. So what do you usually do? You usually ramp up your customer support, you put your engineers on call, and the game is try to respond to your customer complaints quickly so that they don't leave bad reviews, so that your product succeeds. And by the end of the first year, hopefully your product is pretty stable and you can start thinking about your next product. But usually that's not really what happens. And I hope there's some firmware engineers in the room that are young enough that didn't have the pleasure of playing with their Tamagotchis. But you got your old products that you're ready to move on, and they're out there and they're starting to experience new problems. It's no longer the big new environment that you didn't see before, but it's the edge cases, it's your flash chip. An example we've seen before is you keep writing to a same area of your flash, it degrades, it starts to respond slower, and then it triggers watchdog timers and your device is reset. You spend weeks of seeing onesie twosie issues here and there, and then suddenly it's a widespread issue, and you're pulling all your engineers off of NPI, new product introduction, and bring them back to work on your legacy devices. We actually see over 50% of R&D being spent on legacy products, maintaining devices already out in the field and not working on the new devices. So not only are you spending way more on your engineering to launch less products, but engineers don't like working in those old products. They want to work on the new sexy products. So that's what Memfault and NXP are going to talk about, how we're improving your lives, making your next product development or your existing one a lot better experience. So our agenda today, we are going to do, of course, an introduction to Memfault and the NXP products we're talking about. But we're actually going to be doing a bunch of live demonstrations. So Kyle's going to take us through actually setting it up. So by the end of the day today, you could have all of this greatness working on your NXP RT1060 development kits. And they will be live, so stay around. You know how live demos are, but I think we'll get through it. And then we're going to do Q&A and take any questions you might have about getting started. So first, I'm going to ask a poll question, and it's all about your experience with NXP so far. Of course, this is about our NXP products and how Memfault supports them. So I'm interested if this is your first NXP product, you're just thinking about it, or maybe you're just here to learn about Memfault and NXP in general. The results are starting to roll in. Wow, we got a lot of people on here, so it's getting on there pretty quick. Definitely a lot of people who are here to learn, but we have a fair amount of people who have used other vendors' MCUs, so it'll be exciting for you to see how NXP is supporting you compared to those other vendors. And then a good split between it being your first product and you've released a product before. So I'm going to end the poll about now. It seems like, and I'll share the results. So yeah, it's a nice even split across the board. So I think, you know, those who have made products before, the challenges above are probably pretty interesting to you. Those who haven't been there yet, we're going to show you some cool stuff. So how do we solve it? What is Memfault? What are we going to talk about today? So Memfault, I mentioned embedded observability. It's about giving you the DevOps lifecycle of an embedded device, like you're able to see with tools like Datadog, New Relic, Sentry for your server, virtual machines, and web applications today. That doesn't exist for embedded devices in the past. So what we're trying to do is at the far right, the operational side of the diagram, give you the ability to, in near real time, operate and monitor and observe your devices, and then see issues as they're happening before that customer complaint, before it takes a device completely offline, and then give you that hardware debugger back while the device is in the field, providing all of this feedback loop back to your engineers, who will have a view through a web application to inform their coding, inform their design, start using this tool in their dev and test, and then bring their software out with OTA management. So it's those three pieces of monitoring, debugging, and OTA management. And that's how we're helping people, hardware teams, build better software. What actually physically Memfault is, it's a very lightweight SDK, so customizable, openly available SDK that you can embed in almost any size of MCU. Today, the MXP RT1060 we're going to talk about. And with just 3.5 kilobytes or so of flash and a kilobyte or so of memory, you can get all of this visibility to the field. And then back in your office, your product managers, your engineers, your support teams can all use collaboratively a web application and a view into all of this data. And when I say data, what do I mean? The data required to proactively maintain your devices. So to be able to find issues, to be able to understand them and fix them without doing an RMA, without doing a visit on site, a drive around the world to go bring your hardware debugger to the device, you need a few things. You need traces and errors. So what we're trying to do is expose a day ago a problem happened. How do you see everything about the state of your device? Was it a memory fault or stack overflow? You want to see what are in your registers? What was the stack trace? That kind of information. We want to give you metrics, so time series based data, and the ability to see things like, why is my battery life worse on this version of software? Why was the connectivity dropping, or how often was the connectivity dropping when I experienced a certain error? Compact logs, so everybody has logs to some degree, hopefully you have some logs. But there's way more to logs to actually make them useful. So can you get them off the device efficiently when there's a problem so that you can continually track these things and not do it in a post-haste manner? And can you deduplicate them? Can you understand and correlate them to the problems you're having? And finally, delivery. Data is not one way, it's bi-directional. And you need to be able to get your OTAs, your updates out to your devices, and then also relay back the information about how those OTAs are progressing, and also see against all of your issues and your metrics capturing, what are the changes? So this is the data you don't have today usually, at least not across the board, and not in a way that you can easily and quickly verify what's going on. And that's what Memfault is providing to you. And what does that end up looking like? So here's your hardware debugger kind of view of having a GDB session or something like that. But while your device is out in the ocean, like some of our customers have buoys that are solar powered, and literally an RMA or an engineering visit means an expedition. And we're giving you this view back in your office from the crash that happened 2 days ago, a stack trace, what's in registers and variables, and we'll demonstrate this live and show you a bit more. And that's just a debugger, which is still kind of a reactive thing. Today, you're looking for that information once you know there's a problem. What we're trying to do with Memfault is at fleet scale, hundreds of thousands of devices, tens of thousands, millions, be able to see all of the issues that are possibly happening, and then quickly change that from a week-long investigation to logs to hopefully find some correlations to an instant report of what my top issues, my newest issues, how many devices they're affecting, and traces. And again, we'll show you more of this in a live demonstration shortly. So that brings me to poll number 2 before I hand it over to Kyle for some of the exciting demonstration and introduction to NXP. So thinking to your current workflow, how do you monitor and troubleshoot your devices today? And I will launch this poll. All right, you should see the poll showing up on your screen. Oh, go ahead, Kyle.
No, I think everyone on the call has no issues.
Oh, yes.
Yeah.
Yes, I'm sure we all have our perfect devices. Oh, 2 people so far have never had an issue. I like to combine C and D though, because I think if you don't have any issues, you probably just don't know they exist.
Oh.
All right, so the results are trickling in. Give it a few more seconds. And yeah, other than those of you who don't have devices, I'll end the poll here and share the results. A lot of you use logs to investigate the root cause. So that's great that you have logs, and that's a very common thing to do. But I think you know the challenge is that, let's say you have 10,000 devices offline. Usually you have a lot of logs to go through. And talking to the customer is the other most popular one we always see. That's the way the embedded world works. I like to remind you and think about your experience, say, with Facebook or any web application, social media that you use and you've had an issue. Have you ever talked to their support teams? No, because they have, as soon as you had an issue, they already knew about it and they're working on it. So that's what we're talking about here today. Before we go deeper into Memfault, I'm going to hand it over here to Kyle to introduce the NXP product line and also give you a live demonstration how you can set it up real quick on your device.
All right. So as I mentioned at the beginning, this slide just goes a little bit more into what I meant by I'm in charge of the MCU ecosystem at NXP. So I work with a huge team of excellent men and women to develop these tools that you work with at NXP, our MCU Expresso IDE, our configuration tools, our security tools. We have a large amount of infrastructure in our software to make sure that when you're developing with NXP products, everything you need is at your fingertips. And so that is what we work on a daily basis. But if you look down at the bottom, a bigger part of what I think we're working on now is working with third parties, making sure that we have that new tool, that new debug environment that we're missing in our environment for our customers. And so that's, as I mentioned, why we're working with Memfault. It's, as Devin just showed you, the ability to diagnose all these connected devices is becoming more and more difficult. And so NXP is working with Memfault. I'm working with our software team to make sure that it's tightly integrated with the Memfault SDK. And as I mentioned before, we're, if you go to the next slide, Devin, we have a broad offering, as many of you may know, and we have, your introductory, just true traditional MCUs. Then we have what we're going to focus on today, which is our crossover, sort of high-end, high performance processors. And then we have our MPUs, or multi-core MPU, MCU devices. The ability to have those devices deployed in the field and have the ability to debug remotely is absolutely going to become important in the future. You can see some of these applications down the bottom. Wireless connectivity is the obvious piece, but we're seeing a lot of industrial controls. We're seeing voice and audio products proliferate across everywhere. And those are all connected and they need to be troubleshooted. And so that's why we're excited to roll this out. And so today, as I mentioned, we'll focus on the RT devices, but this is something that the ecosystem team at NXP is working with Memfault to make sure that it's on our MPU products as well as some of our non-Ethernet connected devices. So let's go to the next slide. So this has been a work in progress with Memfault, and I am extremely excited to share what the Memfault team put together. This was something that NXP has partners, and we went to Memfault and we said, we really want to work with you guys, but we want to deliver something to the customers that they can get up and running and really see the value of both Memfault and NXP working together. And Memfault delivered. This is going to be exciting. So if you go to the next slide, what I want to do is spend about 15 minutes and show you how easy it is to get started. This is something that not only was I able to go through the demonstration that Noah put together at Memfault, but I was able to transition into 2 other boards that I have inside of that same family. So the instructions, the process is so easy to get across that I was able to take what I learned in the demo and then apply it to 2 totally different platforms. So to get started, you can have these slides. We'll distribute them at the end. You can go to this, this document on the Memfault website, which we'll walk through quickly. And then obviously this is the evaluation kit. And Colleen mentioned, we do have a few of these and we would like to give them away to some of the attendees today. So what we're going to do is have some questions at the end. And for those that are asking good questions or maybe answer a tough question from me, you'll receive one of these kits. But let's jump right into the demo now. And what I want to do is I'll share my screen and share with you just how awesome this Memfault demo is. So this is the website. I showed you that document in the URL on the last slide, and it's a very easy guide to follow. You just go to Memfault docs, MCU getting started guides. And what this did was it really put together a project for you, and it's in 2 parts. And the first part is just to make sure everybody gets started the right way. So it's installing the right SDK from NXP, it's installing the MCU Espresso IDE, and getting a base project up and running so that you know there's no issues, you're ready to go. But then the second part is the exciting part, and that's where Memfault introduces their SDK. As Devin mentioned, it's small, but it's powerful. And then there's a demo project that actually took that SDK and ported it to the 1060. And so that's what the second part is. And in the next 10 minutes, I'm going to share with you some of the things that I found exciting, that were helpful, and some things that I think you'll find interesting with this example. I'm not going to go through the whole thing. As I said, this is a quick starting guide, and you should be able to get through it in no time yourself. But I'll skip through and share some important things. So the first thing that I think everybody's going to run into is like, hey, how did you come up with this example project, and how can I get started with the SDK? The very first thing that Memfault introduced was, this is the example project that they based this demonstration on. This is something that NXP has been providing to customers for our RT platform for a while. It's a reliable demonstration that connects to the HTTP server, and it uses FreeRTOS. It's very reliable. So Memfault took that. So what I'd suggest you do is, if you copy this to find out the right SDK or why we use the SDK, I like to go to the NXP website, mcuexpresso.nxp.com. And on this, you can develop your own SDK or investigate the contents of the SDK. So what I think was helpful is when I heard the Memfault was using this specific example, I just went to this filter choice under examples. I typed in the example that Noah chose, and I can select it. And inside of this tool, it'll tell you which boards are supported, which processors are supported. So if I click on that real quickly, you can see, as I actually showed on that slide, this supports all of our crossover products. So you could take this porting guide, and I'm going to show you it on the 1060 device. But if you have the 1020, the 1170, or some of our other RT devices, they have this, this example in their SDK. On the right, you'll see it's in our version 2.10.1. And if you click this button, you'll get an archive file. And I'll show you how you use that archive file to quickly get up and running in the IDE. So I thought that was a good explanation of where the example project comes from and how to get the right SDK and potentially target other platforms that we're not showing today. So now that you have that, you have the SDK in this archive format. You're going to have to install the MCU Expresso IDE, and that's fairly straightforward. You just go to the NXP website, put in MCU Expresso IDE, and you'll be able to install it with its default configurations. But you're also going to, in the instructions that are in the Quick Start Guide, it'll introduce these two Memfault software packages on GitHub. And so you're going to want to clone these and bring them into your local laptop so that you can create and modify your NXP project inside of MCU Expresso. And so I wanted to show in the SDK right here, there are some script files. And there's one specifically to modify an Eclipse project. And that's what we're going to do next. Is I just want to show you how quick this was and easy to get started. So why don't I'll bring up my MCU Expresso IDE. So this is the latest version of MCU Expresso, our IDE. We're going to jump straight into the developer perspective. Down here, you can see the installed SDKs. This is our installed SDK tab. And you can see I already have installed that archived version of the 1060 SDK. But if you were to follow along and you just go to your downloaded zip file, you just drag that into there and you immediately are set up and ready to do exactly what I'm going to show you. Very easy to get started. So when you have the SDK started, what in the Quick Start Guide, Noah has very well detailed, is you go over here to our Quick Start panel and you import an SDK example. At that point, you're going to follow the instructions and you're going to pick that LWIP example project, and then you'll create it with a few custom settings. That will load your default project into your Project Explorer window. And so you can see I've already done that in the interest of time, but this is just the default project that has been created through that wizard. But as you can scroll down, it only has the default source files. This is just like your own application with no Memfault support, no Memfault SDK components. So what I wanted to show, as I showed earlier, was that script file that they provide. I thought this was a really great way to take this default project and introduce it to have Memfault components, for it to have the Memfault project files. So why don't I do that real quickly here for this example. So the quickest way I've found as a trick is if you right click on the project and then you go down to utilities and you open a command prompt. The nice thing about that is it puts you in a terminal with the exact root of your project. So when I run that script, I'll show it actually calls out the root and you're actually in there. So why don't I jump back real quick to the getting started instructions. So if I scroll down, we've done all these steps for creating the project. What we're doing now is we're going to run that patch script. And then it's going to add all the Memfault source files that may be used by you or in our example into the project. And it's right here. So I'm going to copy this command. And then I'm going to go back to that terminal. And I'm going to run that script. Now you're going to have Python installed. but it's worth the installation time because I'm going to go, all I have to do is change the product or the path. So it's going to ask me, where's that script file? So I downloaded it into a Memfault folder. So now it knows where to find that Python script. I already told you that this terminal is opened in that project directory. So it knows that's where to put the files. And then it's going to ask me, where is the Memfault SDK located? And it's in that same Memfault folder. And that may be your Git repository or wherever you put it. But if you make that change, now you're ready to run this script. And what it's going to do is use the Memfault SDK. It's going to take the components that are required for the demo. So you can see here for the things we're going to be doing, it will extract those and put them into the Eclipse-based project located in this location here. So I do that, and clever little encouragement there says, hooray, everything worked great. But you know, some of us like to actually see if it worked. So if I go back to my project, I go here and I scroll down, now I have these Memfault library SDK components. And so without a lot of work, I was able to get those in there properly for the examples, and really just to if I wanted to start on my own with Memfault. So real easy way for you to get started. There are other things you have to do, and as I mentioned, that those instructions are very well written. So I would take the time, go through, you're going to include these in your build. You have to change some of the linker settings and some other things that you're going to do. You're going to copy the source files from the example project, and that's going to get you to this working project. And as I said, it took no time, very clear instructions. But what I thought would be great to end with is I'm going to show you a couple things in the code that were modified, and then show you that debug perspective that you're going to gain, the traditional desktop versus the cloud debugging. So first things first, a couple modifications that are important. If you go to the client file, you're going to have to modify this to include your specific project key for authentication. So when it connects up to the Memfault server, it's going to ask for the key, and then this is associated with each of your logins. You'll get a free account, you'll get a project key, so that when you send data to Memfault, it's going to associate it with your account, your project, and it'll start showing up on your dashboard. So that's a fairly easy modification to the default project. The other thing that they do is how do they instrument your project to get this information that Devin talked about, all these fault conditions or asserts. So what they've done in their library, in the SDK, they have some templates, and they have some files that you can add into your project. And just some examples here is they have already, let me go here to 245. Yeah, right here. So these are the default exceptions for the Cortex-M SimSys devices. So you can see here, if you have a hard fault, if you have memory management issues, if you have a bus fault, they already have it instrumented to cause an assert, to get the program counter, get the link register, and send it up to the cloud, send it to your connection. So you have that data. There are other instances where in your code, you may want to put in some asserts yourself. Let's see if I can find one right here, where if a timer is not, you're meeting a condition that you did not expect, it will cause an assert, share that data with the cloud. I'm not going to go through all this. Personally, I'm not an expert in this, but what I will tell you is that Tyler wrote an amazing blog. It was called Asserts in Embedded Systems. After this webinar, if you're interested in this, read that article, because within a 30-minute read, you're going to really understand how you can enable your code, get a real clean log, and get that information up to a remote diagnostic like Memfault. So that's where I would stop on my enabling the code. So now you've got your code enabled. Why don't I show you real quick? So I haven't made any changes to this project, so let's just build it. So I'm going to plug in my board. Make sure I plug it in the right way. All right. So we're connected, and I'm going to hit the debug, as all of our software engineers on the call are well aware of and familiar with. With that, I'm going to have a serial terminal, and in the instructions, they actually use the pi serial command, and I just wanted to share this because I thought it was very useful. So within my command prompt, now that I have Python installed, I just do that command and I get the port that my board's on, and then I can do pi serial dot miniterm, and I just do COM18. I put in the baud rate, and I have a terminal. So I don't have it will work with teraterm, it'll work with your other terminal programs, but I just felt that this was a good example shown in the quick start instructions. So now if I go back to our project, it is stopped in our main as we expect. It's ready to be debugged, and there will be no errors, right? There never are. But let's say there were. So let's run the program. We'll resume all. We'll launch our terminal, and we should see the Memfault logo along with some status information that was printed out by Memfault. What they've done is they've put in a command here called crash. And by doing that, I'm causing a hard fault. This is just a test for you to test the ability for it to catch conditions. There are other crashes, other things you can do trace. There's a lot of other options in the menu. But I wanted to show you the crash because now if I go back to my terminal, you can see what happened, right? I'm on my workbench. I have my IoT device, and I had a fault condition. And now as a software engineer, I'm in a comfortable environment. I know I have my call stack right here. I can see that these functions were called. As a matter of fact, if I go to the shell, this is our terminal program routine. And if I go to variables, I can see, in fact, I hit a carriage return right before the crash condition occurred. But what happened? Well, obviously this command, this routine was run. It had 2 arguments passed to it, and one of them was a crash type of 1. So immediately, as a software engineer, you have all these at your facility, right? You have some other, register values, everything at your fingertips. But now, how do we get that up to the cloud? That's the whole purpose of this webinar. Well, I think this is cool. So let's restart our board since it's at a break point because of the hard fault, and go back to our terminal. And if we cross our fingers, because this is a live demo, it reinitializes the network interface. And what they've done here is every 20 seconds, they're going to send a heartbeat. They're going to send battery level, maybe the stack memory levels, some timers, some valuable information that might be helpful for you to understand what your device is doing. But in some conditions, as we just saw there, it said, whoa, I've got a big update to send you. I have a core dump, and it was caused by a crash, and it's sending it to the cloud. It also will send the heartbeat data, but this is more important. Well, how do I see what happened? I go to my account here, a normal fleet dashboard that Devin's going to spend a little bit more time on. But if I scroll down, I see, oh my gosh, I have 3 devices. I don't have as many as Devin, but I'm having some hard fault conditions. If I click on that, I can see that a few seconds ago, oh my gosh, a few seconds ago, it's live. So a few seconds ago, I had another fault condition. And if I look down here, I get that same remote access to a debug environment. So now as a apps engineer or a support engineer, I can go through here and see those same values. I can see the register values, 2 arguments, crash type was set to 1. I can see that the customer hit a carriage return. They're not supposed to do that. Bad idea. They're able to see global variables and statistics within the device. So you have a very similar environment now to do that remote debugging that we've been talking about for the last 20 minutes. So I think this is a great evaluation. like I say, it took me a couple hours, and I'm not that savvy. I'm sure some of you on this call could probably knock this out in an hour. But once you're done, you're going to be impressed. You're going to say, this is something that if I instrument my project or my product, I could probably provide this to my software team and support our product a little bit better. So with that, I'm going to stop and turn it over to Devin. Devin, why don't you spend a little bit more time on some of the other parts of the dashboard that you do a better job of explaining.
Yeah, absolutely. Thanks, Kyle. Thanks for showing how relatively easy it is to set up. Now, quickly you can get to that remote debugging. I really enjoyed how you kind of compared the hard debugger, connected to the device versus the remote. So what I'm going to do here is I'm going to jump out and show you a little bit around Memfault, kind of from the top down, take you through a day in your life, actually multiple teams in your organization. So here's the Memfault dashboard. Kyle just started to show pieces of it. One thing I want to highlight to start is that this interface, it may look a lot at first like a device management interface. You may actually still keep your device management and use this really for device performance, behavior, diagnostic monitoring. Everything in Memfault is for the purpose of helping you detect issues before customers complain about them, before it takes devices offline completely, and how to get down from a bunch of devices offline to actually what core dump you want to look at, which stack trace you need to see, and actually fix the code. So at our top level dashboard, that's what it's all about. We do see the number of devices we have online. So this example is actually a smart sync. I know with the RT1060 processor, smart home applications are really key. Maybe you have like an Alexa enabled dishwasher or something like that. You can think of that for this example. So you have 340,000 of them out in the world, and we are tracking what kind of software versions they're reporting, because obviously the version of your software is going to be associated with any bugs that you may have. You can actually toggle this and look at that in the terms of the percentage of devices that are on a certain version, or see it on the raw levels. But after that is where we really get into debugging and diagnostics. So the key is, and I want to pause here and make you think about your day-to-day lives with your existing devices. A trace is a moment of interest, one of those asserts, or a hard fault or a Memfault. If yesterday on 6/27, 90,000 of your devices experienced some sort of issue that you had been capturing traces on, how would you know? Maybe you see this in your device management interface and you see a bunch of devices went offline, didn't send data for a little bit. What's your process in the morning? The process is usually look at logs, look at 1, look at 2, is it something similar? All of those things. What we do is we take all of these traces we've seen and deduplicate them, analyze them, and say, no, it was actually 5 problems, and they affected 20 to 30,000 devices each. And here's a quick view of what time frame they came in. So I already know maybe what my biggest hitter issues are, and saved potentially days or weeks of effort just trying to track down where in the code the issue is. We also give you a reboot reasons chart. So this is really interesting, especially when you look at it on a normalized basis per 1,000 devices. And this is all the reasons why devices are going offline and coming back online, why they're rebooting. So how many hard faults they're having. Some of the reboots are just going to be firmware updates, which are probably a good thing. User resets could be questionable. Why is a user powering off and on the device? Are they trying to see something different? And you can click into all of these and see the subset of devices that are actually experiencing these reboots. And more on the point of what's happening with these 90,000 devices yesterday, we have our newest issues. So just the issues that have occurred in the past couple days. And we see there's still actually 5 issues. There's some different issues than our top issues, which are across all of our history. And we see 10,000 devices are experiencing a hard fault like Kyle showed. Maybe that's the one we want to dive into a look at first. You do though see 30,000 devices hitting this particular assert. So this may be a bigger problem for us. To the right of this, device alert incidents, I want to call out that we're talking about proactive here. Like you're able to see all this. This is not customer support tickets. This is your devices telling you they're having problems, and they're telling you what problems they're having. And you don't have to sit here and stare at our dashboard to figure this out. You're going to get an email like this in the morning, and you're going to come in and you're going to see, oh, the device I'm responsible for as an engineer or in support and operations or even a product manager, this device is having a new problem. It's an assert. And we can jump right into that with our, this is an NXP device, drop right into that core dump that Kyle showed you through. So this is how you become proactive and not reactive. A couple things I also want to show you is the concept of metrics. So again, at fleet scale, we're capturing those heartbeats, which by the way are configurable. So 20 seconds is what we do in the example. But over time, it could be weeks, months, whatever. You can capture metrics from your device. We have a whole API for that and report them into Memfault. So here we're looking across all of our devices, the average battery drop per hour. And so obviously lower is probably better in terms of average battery drop per hour. And we can see over time how that changes. We can see minimum stack used bytes and things of that nature. Even we can do issues. So memory faults, a bunch happened yesterday and none today. What's really cool is in terms of being iterative and thinking about your OTAs and how you're improving your code once you found the bug in our debugger interface, is being able to compare two versions. So say we want to look at our production devices versus all of our devices, or even a specific version of our software, 1 versus 2. We can do that here and start to see how our changes to our application are actually impacting anything from issues to signal strength, battery life, things of that nature. Now, where are all these metrics coming from? This is all at fleet scale, which helps us identify where to look. But if we go down and look at our devices, this is our device registry, by the way, which is behind the scenes capturing information from your device, when they were last seen, and software versions. If we look at one of our demo devices here, we have down at the device level a bunch of metrics. So these are the time series based data that Kyle mentioned. Right now in the example code we have set up for every 20 seconds. We're capturing this information like battery life, like flash writes, CPU utilization. And what you can do is start to see, okay, I'm looking at my battery life over time here. Suddenly there's a big drop off. We can say, look at our CPU activity for that time frame and start to understand what's going on, or maybe what we're doing to our flash controller, which is really cool in itself. But if we go to our timeline view, which is a little bit deeper dive and richer information associated with that, we can see all of these metrics overlaid with our traces. So that when the asserts happened and when resets happened. So for instance, right when this battery problem started, a user reset. Maybe we would also have traces around this time point that would signify what went on. Maybe it was an update of the firmware, which would be really obvious. We do also have the ability to associate all the logs you already capture with the devices here and in the view of the devices. So I want to go to one more thing, which is our OTA part of the environment. So you may do OTA in your device management. You may have your own custom OTA environment. That's all fine. Everything about Memfault is an SDK, an API, and you can enable and disable what you want. In our OTA environment, we give you the ability to, first of all, group your devices into these cohorts. Cohorts are actually what you can use across the entire platform to filter any of the data into different groups. So you can compare your beta devices in production or version 1 versus version 2. Here we have, say, a production cohort where we have 175,000 devices in it, and we're targeting a certain software version with all of them. We can describe a rollout to our next version, apply it, even do a staged rollout where we incrementally roll out our devices with their updates. And then within that group, you can actually do pretty rich examples of complex rollouts of OTA. So when a device gets to a certain version of hardware or software and you want it to jump to a future version and you want to visualize where are all my devices in terms of their life and their upgrade process, we make that visible to you. Those OTA releases are stored over here in our OTA environment, and you can manage and organize them. You can even manage for some platform Delta releases. So that is the key aspect. Again, in our issues area, if you really dive deeper, say below the upper level dashboards, you can even see, the breakdown of traces versus devices. You can filter, slice, dice all of this information. And again, all your customers may have not even realized they had a problem, and you have all of this rich information to improve your product. So with that, I'm going to drop back into my slides, hopefully gracefully. All right. So that's Memfault. That's a high level. There's a lot more features behind the scenes, and I see a bunch of Q&A. We'll get to that in a moment. I want to talk about a use case. So this isn't a new thing. Actually, the partnership has been recently launched with NXP, but Memfault has been working with NXP devices and real customers with their devices for a long time now. Geo Green Energy Options is a customer of both of ours that's working on some new products, and they're leveraging NXP and Memfault together for them. Geo Smarter Energy is making smart energy management systems like in-home displays, they call them IHDs, that help customers in mostly Greater Britain area manage their home's usage of power and save them money on their electric bills, save the country in terms of energy usage. And they choose to use the NXP processors, first of all, because they're very efficient and give high performance. These have multimedia aspects, Wi-Fi connectivity, so great uses for the RT series of processors. They have great power, dynamic power controls, so that's great for their mission. And they have some of the best tools like Memfault. Memfault is working with them because Geo's actually launched 6 million devices already in their past. So they're an experienced product developer. They know what it takes to launch projects. They know what the pain that I talked about earlier in terms of launch, the first year and after that. And when they saw Memfault, it was pretty clear that this would help them get to market on time, have a good experience, and continue to deliver the highest quality products in their market segment. And these aren't obviously our only customers. You'll see on our website other popular names like Logitech, Carrier, other names you would know that have great engineering teams. And this isn't about not having a great engineering team. This is about knowing what it takes to launch a product and to manage it well in the field. So in summary, we've told you about how to basically transform your embedded device development and deployment with embedded observability. Go from the logs you have in our poll, a lot of you said you work with these logs, to go from those to real reports, remote debugging, and to go from RMAs to OTAs. No longer do your truck rolls. Try to do things just over software updates and be able to have full control of your devices and happy customers. So finally, how to get started. Kyle showed you a bunch of this, but I wanted to put this in here for you, both at Memfault and NXP. Obviously, there's a lot of information about all of us. Memfault's SDK is actually on GitHub and available for you. So you can go see how actually small it is, how easy it is to integrate. And our documentation is all open and available on our website as well. Just check across the top, there's a bunch of links. Our integration guide is linked directly here to get to that guide that Kyle was showing you. And a link to the product page if you'd like to buy an RT1060 development kit. And finally, reach out to NXP or Memfault for more help. We can help you with any of the challenges you might come across. Licensing, you get NXP, cool thing, part of the partnership, you get 100 free devices. So you can actually go right onto our website or click this link and register as an NXP user. And then you can get some free devices in our environment to use for an indefinite amount of time. And do ask Memfault or your NXP sales, both are read up on what this relationship's about and what the tools are for. And we'd love to talk to you, help you get started even faster than just going on your own, and be happy to talk to you about it. And lastly, check out our Interrupt blog. You may have heard of it before. You won't see much about Memfault there. It's really a place where anybody in the industry writes about their experiences with different IDEs, with different chips and all of these things. We actually have on the background, when we get to Q&A here in a moment, the famous and esteemed Noah Pendleton, who, if you frequent the Interrupt blog, writes a lot of thought pieces there. So I encourage you to check that out. It'll help you build better devices, no matter what tools you use. And so with that, I will open it to questions.
All right, I'll let you take a breath. You did a good job bringing us in, Devin. So Abhishek asked a question that I may be able to answer. But he asked, how much data space does the diagnostic data take in the data transmission packets to the server? And that was really the core topic in that blog that I talked about, where the way you set up your asserts and what type of data are you going to send in your logs or in your data transmitted is critical. And so that is one thing covered in that blog. And so you saw in the hyperterminal, or in my terminal window, the heartbeat is about 60 bytes. And that's very specific for the metrics that Devin showed. But the core dump is right around, I believe it's 2K or 2.5K. And that was that 512 blocks that were sending across. But the other assert information that you might have really depends upon how much data you want to capture. Are you going to capture file names versus program counters? So that's some of the answer that you wanted there, Abhishek. Anything to add, Devin?
Yeah, no, you did a good job with that. Just a reminder that like our SDK is openly available. The APIs are all there. What we do with these examples is really put together a good starting place and kind of what we expect you to want to do. But we have customers using Memfault on anything from NB-IoT and LoRa type environments with super low bandwidth availability, really battery constrained environments where they can only do a little bit here and there. So it's all very configurable. We literally have devices that check in with a little bit of data once a month and things like that. I think a similar question that I see in the chat is something about network connectivity issues, and it's kind of related to sending the data up. How does Memfault generate and send logs from devices that may be now offline? So a couple things. For issues with connectivity, like breaks in connectivity, we give you the ability to really get the information up to us whenever you can. It can be over the period of days or weeks. So if you're only getting connectivity once in a while, you can send the data up at your leisure, and we'll then represent it for you and tell you when the problems happened. And I think also part of this question was, what about, well, the device is offline, how are you getting the data up? It's interesting to explain this sort of in the view of the life of a core dump. The core dump is our data capture that you're seeing that debugger representation from. When a device crashes, so Memfault is sitting there in your fault handlers or in asserts, and that's usually a place where you get the device under control, you reset it and come back online. Usually, most problems, you do get back online to some degree because you reset the device to a clean state and you got back in a better environment, and that's when we get the data back up to the cloud. You would store it on a non-volatile piece of memory in the meantime. However, you can also, if you do get physical access to the device, you can pull the core dump off in a terminal or raw off a flash, and you can just even copy and paste it or upload it to Memfault's interface, and it'll do all the processing and include it in all of your other data. I see some others on here. I don't know if Kyle, do you have one queued up you would like to take? We'll take turns.
Not yet.
Okay, no problem. Okay, there's a question from Brian Sharp about your early slide mentions the i.MX line with Cortex A's. Does Memfault have APIs logging application code for the A's? Is there a turnkey way to get i.MX 8MP, for example? And there's actually a couple other questions about operating systems and hardware. So I'll answer that a little bit broadly first, which is Memfault's designed to be agnostic to basically all types of connectivity, whether you're using cloud services with MQTT as your messaging, or Bluetooth or Wi-Fi. And also it's a C API that's meant to be able to be ported or integrated into most software and hardware environments. So whether it's free RTOS, or maybe you're using an NXP device with Zephyr, we're partnered with Zephyr as well. And you can use Memfault really easily with that. Even bare metal, we have support for that. And it's mostly in the form of integration guides on our documentation. You can see a lot of that there. Also, just contact us. We have experts like Noah here, who's constantly helping us support new environments.
All right, there's a question from Martin. He asked, can you maybe quickly demonstrate what information is required to be uploaded to Memfault? The assumption is it's an ELF file or something similar to be able to get such a core dump and debugging capability. And that's correct, Martin. It is the ELF file, symbol file. In the NXP situation, it's the AXF file, which is just an ELF format. And you can load it up, which is what I did. So I go into my account. When I release a new version of software, I go in, I load the ELF file, and then it's able to decode. It actually will prompt you and it'll say, there's a new alert from that does not associate, it has a different build ID than what you have in your software revisions. So then that could prompt you to upload the right version. There's also ways you can do it in a CLI to where you could just, when you build the firmware, you can use a command line and just upload it immediately. And so that it's up there and you don't have to go through the GUI interface. But it's definitely, you use the ELF image files, and that's how it associates and extracts all the information.
Great. One more question on support for various types of software and hardware environments was the value usage of Memfault with embedded Linux. So I'll be more specific, we have support for most of the real-time operating systems, bare metal, and even Android and embedded Linux more and more is being launched for. So you won't find that information maybe in the integration guide. Do reach out for support on those. We can help you. Another question here was, is there a way to dump trace and logs in offline installation, no internet access? Do reach out and contact us about this. There's ways to export the data from Memfault into your environment. And there's a number of different ways you can deploy Memfault. So happy to talk about that one in a one-on-one with you.
Sean had a question about how frequent can I send the data out? Is there any limitation? So in the demo that we have, it's been instrumented to do the 20 seconds. It's very visible. You can change it to whatever number you want. It's obviously dependent upon your amount of data you're going to be sending up with Memfault. The other thing that was brought to my attention from Noah was you can just not send data and then have conditions built into your application to say, under these conditions, send the data. So if you had a hard fault or something like that, you could say send now, but don't you can have different frequencies of sending the data. So, but it's really, I don't know, Devin, if you want to talk about the Memfault messaging and the quantity of messages and things like that.
Yeah, sure. I guess I would sum it up in that, remember, our founders came from companies that made things like smartwatches with Pebble, wearables like Fitbit and things of this nature, where both bandwidth was limited, battery life was limited. So we've done everything we can to optimize this. One is the fact that you provide your symbolic information up to Memfault's cloud separately. So the data going over the wire is very small. Someone asked, I think in the chat, about how big the actual data is to show that debugger view. And depending on how much memory you want to show and things like this, it can be on the hundreds of bytes to several kilobytes of size. And then the metrics you upload kind of at your leisure. And they're only a handful of bytes per metric. And the frequency, you're really only, honestly, you're not really limited based on an agreement with Memfault. Typically, we expect customers to be no more frequent than 15 minutes to half an hour of updates, so that you're getting enough information while not swamping your device, either in terms of power overhead or network overhead.
So in the chat, Brian Sharp, I shouldn't say your whole name, but Brian asked about support for the i.MX line. And that was what we were talking about, the MPU products, the A core running Linux. Somebody else asked about Linux support. That's being developed. It's something that we're working on. And that's a follow-up question with you, Brian. So we'll have to follow up with you. And that's where the Memfault team and the NXP team can talk to you about where we're at with the A core support and the i.MX family.
All right, so I know we're over time, but we're gonna keep going for a couple more minutes here because we really want to help with answering your questions. But if you have to drop, you're welcome to leave and you can watch us on recording. The next one I was going to answer was there was a question about what if the MCU isn't connected to the internet, but it's connected to a PC that is. So that's where the configurability of the API really comes in. So you're free to do the transmission of the data to the internet any way that you like. We have examples where people have a device that's Bluetooth or physically wired to a PC, for instance, or a gateway. And then you just send the data chunks that are very configurable. You can shrink them down and put them wherever you want, and then transmit that from your PC up to the cloud. There's even a way to do like web Bluetooth and be able to like use your web browser as sort of a web gateway to do that. We also have integration guides for if you use Amazon, AWS IoT. You can package Memfault into MQTT messages, and then on the cloud side of your cloud provider, make a service that just sends us the data. So very configurable. That's some of the integration work. We'll work with you as you onboard with our experts to help you do it in the most efficient way and make it just work within your environment. The great thing about Memfault is it doesn't dictate anything about your connectivity. It doesn't say you have to use this stack, this protocol. It just leverages what you have or what you will decide to have.
All right, Tommy had a question about can I modify how how to compare the data from the crash dumps to be able to select or skip some registers, make sure some are compared and some are not. So in the getting started guide of Memfault, just the generic introduction, it goes through some commands that Memfault has that selects which registers to include, which registers could be excluded. And so that when it's gathering the information, you can be selective. Within the dashboard, that's a different question, but I know sort of what other people were asking about how much data is transmitted. There are routines that specify memory ranges, like you can exclude or focus on specific memory ranges and include that to make it a little bit more precise.
Another good one is the time to integrate the SDK into an existing workflow. So what Kyle showed today was a decent part of it. Obviously, it's going to take a little longer. You could probably get your device together and the RT1060 dev kit and go through by the end of today, have it up and running on your desk. We shoot for if you want to get this out to the hundreds of thousands of devices you already have in the field, you can do that, by the way. Those legacy devices are having trouble. We have examples and success stories of our customers doing that, and push it out in your next OTA to get sort of that level of being ready to send it out. We target with our design to be just a couple weeks of engineering time and then some dev and test, and you can be out in your field in realistic terms. So proof of life really quick, and then a very easy and short integration period. We have an amazing customer success team that can help you through, has seen pretty much every type of device and challenge out there. So please reach out.
All right, well, while Devin's looking at the remaining questions, we want to mention again about the development kit. So I have a couple of these with the 1060 EVKs, and make sure you fill out the survey. I think that's the fairest way, is to allow people to take time to give us your feedback. It's important for Devin and for myself and for Memfault. But those people that fill out the survey, we will draw a few from the names, and then we'll contact you via email, and we'll send one of these out as soon as possible.
Great. Leave the handouts and the free gifts for the people who lasted all the way to the end of the Q&A.
That's right.
That's the expert way to do it. The very last question that I have here is, how hard is it to implement custom error uploaders and examples via BLE? I think that's best answered. So I already mentioned the gateway topic, but I just want to mention too that, again, Kyle showed it to you. There are a bunch of pre-built APIs and fault handlers, but you can define a new metric in just 2 lines of code, and you can create your own named and your own custom crashes and capture crashes wherever you want. And that's really up to your integration. So we have people capturing, the number of button presses during a certain time period and uploading that in one of their heartbeat, or the number of disconnects of a network, things of that nature. So really the sky's the limit, how intricately you want to implement it on your device. So I think we covered all the questions on my side. Any more on yours, Kyle?
No, I think we did a good job. I think we had great attendance, lots of good questions, and looking forward to seeing our activity with all of you and see what the next steps are. Because I know, as I mentioned, NXP is excited to talk to you, and Memfault is more than capable to answer all your next questions. So I just suggest everybody reach out to Memfault or NXP, and let's get started.
All right, thank you. Have a great day, everyone.
Yeah, thanks, everybody.